long mouthful of a topic that I was given. Somebody in marketing came up with this whole thing. Qritrim actually means artificial intelligence in Hindi, which is an Indian language. And this idea started about 3 years ago or 4 years ago in my head, and then put into action about 3 years ago. And the thing was, the vision is another 15 years out. And the concept is, how can each one of you build an AI solution for yourself or for your business without knowing data science, without knowing any of these tools, and do it such that it is one of the best things, not some, playbook. So a future where anyone can know anything, anytime, anywhere, and answer questions they were never able to answer before. That was the idea. It's still in motion. So now the first thing we wanted to do was, if you look at enterprises, AI is the big buzz. Everybody's talking about AI. 3 years ago, fewer people were talking about AI. Microsoft changed the game, announced, and now everybody is talking and everybody's an expert. But I don't know which industry are you from?
Architecture, engineering, construction.
Okay. Other industries, pharma, healthcare. So all of you want to use your data, make sense out of your data, come up with new things to do. And then you say, okay, now what is modeling? How do I create these statistical models? What is this data ingestion? How do I convert images into something valuable, et cetera, and then you put that idea on the shelf and go about your business the old way. So that's what we are changing, our vision. Every human should be able to realize their big dream. This is the true AI. Mission, empower every business and human to solve complex problems. Maybe even your emotional issues, maybe even your medical issues. All those things can be resolved if you can look at. But at the same time, very important that this data be privacy, trusted. Even though you are using information, you want to keep it, your data, to yourself. Now let's quickly, there's a lot of talk about, because of Microsoft, large language models. Well, language is one type of data, primarily text. But the world has a lot of data. At some point, they started moving into images, so the latest version also has images. But there's code, software code, there's audio, there's video, there's architectural drawings, there's behavioral data, location data, 3D models, sensor data. And what we did, so just talk about generative AI. Now it has become a common language, right? But it's been in the works for a while. Back from, even before 2014 was when it rolled out. It was started, 2005. In fact, if I think about AI, my first job was at Texas Instruments in 1986. In 86, TI was working on an AI processor. 1986, that was 40 years ago. So AI has been around, but now we are finally at a stage where we can manage large amounts of data. The good news for us, for our company, is last 3 years I used to struggle explaining it. ChatGPT happened, now everybody understands it, what we are doing, because And we also took some of their language. We weren't talking about it as generative AI, but we were doing generative AI. So here's, ChatGPT goes viral, 1 million users in 5 days, 100 million in 2 months. And people think, okay, the train's left the station. No, it hasn't. There is a lot more to do. So now moving to the other side, okay, the other big buzzword going on is digital transformation. Everybody wants to do digital transformation of their businesses. What does that mean? It means different things to different people, right? If I have a digital transformation of my sales operations, of my marketing operations, of my supply chain, and underlying all of that, besides the technology part that I discussed, is how do you trust the data that you're analyzing? What is the domain knowledge around that data? You go to, I'm sorry, I'll pick on Microsoft, but I mean, how much do they know, depending on this, is about your farming operations? Maybe they do, but probably they know enough about how to work with ADM, Archer Daniel Midland. But my backyard farm, probably no, that's not in their scope. That won't be in their business fit. So you have to understand the domain and understand the complexity and make sure the data is secure. So what did we do? We used this to come up with a new approach. It may, once I describe it, all of you will say, oh, that's straightforward and simple, and why wasn't it done before? But what we have is a system, and I'll just go through the system. We have broken the problem down into 4 parts. It's the same for every one of you. First part is data has to be ingested. You have data sitting in your PDF files, in your databases, in your drawings, in your electrical diagrams, et cetera, et cetera. Last 40, 50 years of knowledge that you don't want to throw away. So it can be in satellite imagery, it can be new data in IoT sensor. We have built a tool where you can ingest any kind of data with a connector. One push button, I have image. Now, what does that do? It takes that unstructured data and structures it. So now, let's take an image as an example. So if I am using that image for advertising purpose or moving video, I want to extract certain things out of it. What shirt are you wearing? What shoe are you wearing? But if I'm using it for security purpose, I want to extract different things. If I'm using it for quality purposes, I want to extract different things from those images. So what we create is ontology. Ontology is basically we look at all the data that is coming in. So it's automatically generated. And the application is a security application. It will create an ontology for that application that maps the relevant information. As an example, somebody may call something a machine, somebody may call something a product, somebody may call something else, and it understands that machine and product and this mean the same thing across these documents and across this database, and creates an intelligent database of all your information. Could be architectural drawings. You just scan it in, or it scans it in, and it extracts everything out of it. What parts, what materials, what construction, what layout, for all your drawings, so you can create that information, creates it. Second thing, after that data, now you have, especially when you look at the LLMs, they are working on a large amount of public data. When I use that LLM in my environment, it doesn't understand my business data. So I have to modify it. Now, challenge is once I modify it, who does that new learning belong to? Right now, it belongs to the owner of the LLM. So you have transferred certain amount of insights and ownership on your private data to the public domain, which you don't want to do. I want to keep my private secret, my secret secret. So what we have is a master data management where it partitions the data out between private and public. Anything that is used to create a revised model or updated model, it automatically knows it creates a new copy that belongs to you. Then it goes into that data, and you have machine data or bot-generated data or false data. It goes and cleans it out, that this is data that is coming from a real source. Then when you save it, you might have a medical requirement of HIPAA compliance or a social requirement of no personal identification, PID should be removed. So it cleans it all out so that when you go use that information for your next step, which is to build an application, because in order to do the first two, there's a lot of AI going on. But we don't call that, this is all running in the background. You don't have to do anything. Then you get to the next step, which is I want to now build something, my application. I want to predict pricing, or I want to predict machine failure, or I want to predict supply chain. So you give it that application. It has a set of models, a dense library of all kinds of statistical, language, audio, video models that it has two approaches. It will look at your application and suggest, here are the models you could use. So it actually, you don't even need to know, it will tell you. And this model, if you use this set of models, it will create this kind of performance and accuracy on your data set. So because there is a trade-off between how fast you want to run these things and how accurate you want to have them, because you can keep running the model and it'll take forever, but it'll be 100% accurate. But you don't need 100% accuracy in every case. So, but you wouldn't want that information fast. So that's what that machine learning is. But if you have experts in your place, they can modify the model. And if you have a whole data science team, they can create their own model and put it into the library. So that's the machine learning. And then final thing is, you have to visualize. Whatever comes out, the marketing guy wants to look at it this way, the sales guy wants to look at it this way, the operations guy wants to look at it this way. It's the same data set, but they want to look at different images of the elephant. So we give the tool to pull that out. So the rest is, data ingestion is your data gateway, very efficient data collection, processing, structuring, integration of all sources, streamlined access. I call it LMM instead of LLM, right? It's a large machine model if you want to create a new. And it has, not only do we have, all the connectors, agents, validators, filters, it's all built out over, and et cetera. It labels it, it organizes it, it stores it, it creates an ontology, it creates a knowledge base. Machine learning, one more part about machine learning is there's a lot of discussion, especially in different applications, in industrial applications, and industries, whether it's a text, we are deploying this in textile manufacturing, in FMCG, in automotive manufacturing, people are using it. Different industries, they want automotive guy will have a lot of compute power running at the centralized location, and they can pull all the data. But textile manufacturing operation in Bangladesh, they don't have that kind of server compute capacity, but they have, nodes at the edge, and the system deploys, figures out the model, automatically partitions what can run on the edge, what can run in the center, and you don't have to do anything. It does the math, it goes out, figures out what is the compute power there, what is the available resource, and partitions the model. So edge models, model inference, model builder, training, security, all that is, it does the development, it does the training, it does the deployment, and more importantly, it has a continuous retraining ongoing built in. So once it's deployed, it is continuously learning as you introduce new data of yours. Master data management, we talked about FINRA compliance, GDPR compliance, HIPAA compliance, et cetera. And pick the domain. We have to pick the domain. ADI is artificial domain intelligence, so if I'm building it for agriculture, it will pick up agriculture terminology. If I'm picking up for advertising, it will pick up advertising terminology and organize the data in that way. Data visualization we talked about. So this is kind of a block diagram of the whole thing. Public database, private database, library, even your library is under a secure system. So differentiators, NLP, computer vision, GAN, it's all loaded. You can go, and interesting thing is we've had like 7 or 8 different clients that we worked with. Each of those clients has worked with multiple implementations in different parts of their business. And the process takes exactly 3 months from start to deployment. Because the way it works is a very clean definition, then there is a drag and drop creation, then there is a training, then there is model training, then deployment. Plus minus 1 or 2 weeks, whether it is a complex, advertising, contextual advertising system, or a simple, electrical diagram ingestion. Because the amount of time it takes to define is about the same, amount of time to drag and drop and create the application about the same, amount of time to train about the same, plus minus a little bit, right? So what we talk about is we are going from, in this case, knowledge management to kind of knowledge creation, because we are really looking at information across machines, across the factory, across the systems, and integrating all that to create a prediction of what could happen with a relative high accuracy. Australian government used this system because it's the year of the millet. Actually, that project was sponsored by Microsoft, Year of the Millet, which is the new superfood that grows anywhere, doesn't require too much water, grows under every condition, and is being promoted as the superfood by the UN across the world. So they wanted to know, where is the production of millet, who's producing it, how much is it, what is the result based on weather pattern, when the millet comes, what does it get turned into, when it gets turned into something, does it get used in cornflakes or cereal, and when the cereal sells, is the value of the millet 10x when it's sold in the cereal versus when it's sold as something else. So they were trying to figure out the whole pipeline, and they built that application in 3 months, rolled it out. It goes in, collects all the data across the internet, updates on a real-time basis, and says, okay, this is the production here, this is the production here, this is the use here. ADM is doing this, and Frito-Lay is doing this, and gets it out of all public data, right? Because they're, at the end of the day, they're selling those products. I think this is all the same use cases. This is deployed with, actually I can disclose this. This is Denso. Denso is, for the people who know it or don't know, it is the largest automotive OEM supplier in the world. $60 billion annual turnover, 300 factories across the globe. They make everything, right? Toyota only assembles them. GM only assembles them. They make the air conditioning, the compressor, the transmission system, the brake system, and ship it, right? So they are using this for predictive maintenance across their production lines. They want to predict, and this thing goes in, and in order to do that, we had to took all their documentation, ingested it, created a digital representation of their entire manufacturing line, including every step in the process, every machine that is used. And then when there's a machine failure, they had years of machine failure data, ingested it. They had years of maintenance data, ingested it. And within a week, they can see everything in front of them that shows, okay, this is the pattern of failures and data and processes, and then they can build on it. Okay, now here is the place where these machines fail most often, or it takes the longest time to repair, or it takes a lot of spare parts and expenses. So if I could, fix these points or predict ahead of time, then I can have a better answer, right? Better results. It's kind of like, moving from, you used to have a car that you said every 3,000 miles you have to change the gas. Now, there's a flag that measures the gas, and sometimes I don't change the gas for 10,000 miles oil, because the oil hasn't degraded, right? Before it used to be every 3,000 miles, take it in, change the oil, change the filter. So here we get one step ahead. It is predicting that this machine will fail in 30 days from now, and this will be the failure mode, and this is what you will need in spare part inventory to address that failure. This is the repair you will need to perform. It is predicting, and it will say it's 90% accurate, or it is 10 days from now, and it is 99% accurate, or it is going to happen in 2 hours, and it's 100% accurate. So you can make the appropriate decisions, or they can. Quality control, we understood all their failure. This is a different for a garment manufacturing line. They use the system to figure out what were the failures, where is the thread, where is the operator making a mistake, where is the line making a mistake, and figure out from image processing and analysis of the image and put in place a quality control system. Supply chain or optimization, digital twin, we are putting together for a FMCG company a complete representation of their process. So the tool itself is very easy to use, but the industries, what we are realizing, that the industries are not even ready for that level of ease. They say, okay, this looks great, but can you do it for us? Even though, because these industries, they are not in the business of software. They're not in the business of, and especially the lower level industries. I mean, automotive is probably one of the most advanced. Semiconductor may be the most advanced out of it. But most of them, they don't know what, the manager won't know even if he hires software engineers what to do with them. So the next step, what we are looking at is, working with system integrators and just we deploy. So think of it as, this is the SAP of AI. And the system integrators SAP consultants probably make 10 times the revenue SAP does. That's okay. That's the plan. This is an example of where, there was a lot of electrical drawings that they had. They were all in PDF form. They said, we need a digital output. We pushed it in and, did computer vision, did analysis, did labeling. Automatically, it creates a full representation, electrical representation of the piece parts, the components, the wires, the connections. And so our goal is to amaze you. Questions? Whatever problem you have, we can help you figure it out. Sounds good.